Okay, we're being asked to draw a Lewis dot structure for Formamide CH3N00. It gives us some more information structurally that we have one carbonyl group and one amino group, which should be very helpful to us. Okay, so let's go back and let's just draw this out, and let's see if we can do this. Okay, so this is going to be for Formamide, which is going to be CH3NO, and we have a carbonyl group, which looks like this, where we have a double bond to an O. Okay, so that's a carbonyl group, and then it's asking us also for an amide group, which is an N, H, and H2. Okay, and we'll usually have a double bond or a lone pair on that nitrogen to form that amide group at a certain pH. And so let's go ahead and calculate the valence electrons here. So we have 4 valence electrons from the carbon. We have 3 hydrogens that have 1 each, and so there's 3. And the nitrogen has 5, and the oxygen has 6. Okay, so that's 11, 14, that's 18 valence electrons that I have to account for. So let's go ahead and draw our structure. We're going to draw that C right there in the middle. That's going to be the first one we're going to start with. Number one, you'll get used to this when you draw organic compounds, but the C's, the carbons, are what we usually start off with. They form usually the structure of the organic compound. It's also the least electronegative of these, and so that's one of the rules that we typically use anyway. And so let's go ahead and draw that carbonyl here. So we got C double bond O. We'll put those lone pairs right there to complete that octet. Okay, and then we're going to have an NH2, N, H, H right here. We'll have that lone pair. That's going to be our amino group. Okay, and then we're going to have one more hydrogen here. And so that's our basic structure that we've drawn, and let's see where we're at in terms of valence electrons. I have 2, 4, 6, 8, 10, 12, 14, 16, 18. I've got all 18, and so let's I've accounted for all those, and let's just check and see octet rules. And so that is an octet. That completes that. Octet right there. Octet right there, and each of the hydrogens will just form those duets. And so this, my friends, is a valid Lewis dot structure for Formamide. And so let's go back and let's go ahead and draw this here in Alex, which you guys should already know how to do, but we'll do it anyway, just to get those green, give us the Alex green that we love so much. And so there's our nitrogen right here. Let's go ahead and put that lone pair on that nitrogen, and let's put our hydrogens on now. I have 2 double bonds there. Just get my bonds in place. Okay, let's go ahead and put our hydrogens on. So there's hydrogen, and there's hydrogen, and there is hydrogen right there. And then their oxygen is going to go on here with our lone pairs that we'll put on there. And so there is our valid Lewis dot structure for Formamide. Okay, you should be able to do these organic compounds, I think, fairly simple. They're generally simple organic compounds to do, and more advanced ones you'll end up doing in organic chemistry as you move along.